Have you ever wondered how every device in your home can access the internet even though you only have one public IP address? That's made possible by a concept called NAT, or Network Address Translation, and the most common version of it, PAT, or Port Address Translation. These are used in almost every home and corporate network, and in this video, I'll show you how they work and why they matter. Let's get into it. NAT stands for Network Address Translation. It's a process that lets a router modify the source and destination IP addresses in the packet headers to move data between a private network and the public internet. The main reason we use NAT is to allow private IP addresses like 192.168.1.10 to talk to systems on the public internet. Without NAT, these private IP addresses wouldn't be able to send or receive traffic across the internet because they aren't globally routable. And if you saw my previous video on private versus public IP addresses, this ties directly into that. Because when IPv4 was created, no one expected billions of devices to be online. And now we're running out of public IP addresses. Fortunately, NAT helps solve that problem. By using network address translation, multiple devices on a private network can share a single public IP address. That means an entire office or your entire household can access the internet without needing a separate public IP address for each device. It also adds a small layer of obfuscation since devices on the outside can't directly see the internal IPs of your network. Now let's talk about the most common form of NAT, Port Address Translation, or simply PAT. PAT allows many devices to share one public IP address, and it tracks each connection using something called port numbers. Here's how that works. Let's say your laptop, your phone, and your game console all connect to the internet using the same router. Each of these devices have different IP addresses like 192.168.1.5, .10, and .15. When they send traffic to the internet, your router keeps track of each connection by modifying the source port number, so it knows which response belongs to which device. That way, all three devices can use one public IP address, and your router handles sorting everything on the back end using port numbers. It's kind of like a receptionist or a call tree at a large company. Different employees share the same phone number, but the receptionist or phone system uses extensions to make sure the right call goes to the right person. Let's take a look at a hypothetical home network. Let's say you've got a PC, phone, tablet, and maybe even a smart fridge, all connected to the same home router. Each one has a private IP address. When your phone checks email and your PC browses the web, both requests go through your single public IP, and your router uses port address translation to translate and track connections using port numbers. Without this system, you need a separate public IP address for every device, and that's simply not scalable. Network address translation makes modern networking possible by letting private IP addresses access the public internet. And port address translation takes it further by allowing many devices to share one public IP address using port numbers. It's an essential part of how most networks, including your home network, function every single day. If you found this video helpful, please consider subscribing to the channel or check out the Networking Fundamentals playlist. Thank you so much for watching, and I'll see you in the next one. Take care.